In this video, we're going to discuss AutoCAD fundamentals. The fundamentals that we're going to talk about are the user coordinate system, or UCS, the Cartesian coordinate system, the polar coordinate system, and absolute and relative coordinates. We're going to start by talking about the CAD database and the user coordinate system. Designs and drawings created in a CAD system are usually defined and stored using sets of points in what is called world space. In most CAD systems, the world space is defined using a three-dimensional Cartesian coordinate system. Three mutually perpendicular axes, usually referred to as the x, y, and z axes, define this system. The intersection of the three coordinate axes form a point called the origin. Any point in world space can then be defined as the distance from the origin in the x, y, and z directions. In most CAD systems, the directions of the arrows shown on the axes identify the positive sides of the coordinates. A CAD file, which is the electronic version of the design, contains data that describes the entities created in the CAD system. Information such as the coordinate values in world space for all endpoints, center points, etc., along with the descriptions of the types of entities, are all stored in the file. Knowing that AutoCAD stores designs by keeping coordinate data helps us understand the inputs required to create entities. The icon near the bottom left corner of the default AutoCAD graphics window shows the positive x direction and positive y direction of the coordinate system that is active. In AutoCAD, the coordinate system that is used to create entities is called the user coordinate system, or UCS. By default, the user coordinate system is aligned to the world coordinate system, or WCS. The world coordinate system is a coordinate system used by AutoCAD as the basis for defining all objects and other coordinate systems defined by the users. We can think of the origin of the world coordinate system as a fixed point being used as a reference for all measurements. The default orientation of the z-axis can be considered as positive values in front of the monitor, coming towards you, and negative values inside the monitor, going away. Sometimes you'll notice changes to the 2D UCS icon display. In AutoCAD, the UCS icon is displayed in various ways to help us visualize the orientation of the drawing plane. You may see a 2D UCS at the world coordinate system. You may see a 2D UCS with a broken pencil icon. You might see a right side view of the 2D UCS. You could potentially see a 3D UCS at the world coordinate system, a 3D UCS viewed from below, and a shaded UCS icon. To change this, if you click on the View pull-down menu, you can select Display, then UCS icon, and then Properties. In the UCS icon style section, you can switch to the 2D option. Click OK to accept the settings. Notice the W symbol in the UCS icon indicates that the UCS is aligned to the world coordinate system. We're now going to talk about Cartesian and polar coordinate systems. In a two-dimensional space, a point can be represented using different coordinate systems. The point can be located using our Cartesian coordinate system with x and y units away from the origin. The same point can also be located using the polar coordinate system. For planar geometry, the polar coordinate system is very useful for certain applications. In the polar coordinate system, points are defined in terms of a radial distance r from the origin and an angle between the direction of r and the positive x-axis, which is going to the right of the origin. The default system for measuring angles in AutoCAD defines positive angular values as counterclockwise from the positive x-axis. We're now going to discuss absolute and relative coordinates. AutoCAD also allows us to use absolute and relative coordinates to quickly construct objects. Absolute coordinate values are measured from the current coordinate system's origin point. For example, if we look at our origin here, we move it to the middle of the screen. If you look down in the bottom right where our coordinates are at, you will see that if I'm to the right and up of the origin and above the origin, both of my first two values, x and y, are both positive. If I move over that axis and now I'm left of the y-axis but still up above the x-axis, you'll see that I have a negative value in the x and a positive in the y. If I go down to the left, I now have two negative values because both of them are negative y and negative x. And if I go down to the right, you'll see that I have a positive x because it's going in the positive direction on the x-axis, but negative y. Relative coordinate values are specified in relation to previous coordinates. In AutoCAD, the absolute coordinates and the relative coordinates can be used in conjunction with the Cartesian and polar coordinate systems. By default, AutoCAD expects us to enter values in absolute Cartesian coordinates, distances measured from the current coordinate system's origin point. We can switch to using the relative coordinates by using the @ symbol. The @ symbol is used as the relative coordinates specifier, which means that we can specify the position of a point in relation to the previous point. In AutoCAD, there are 5 methods for specifying the locations of points when we create planar geometric entities. There's the interactive method, where we use the cursor to select on the screen and click. There's the absolute coordinates, and the format is typically x, y. You type the x and the y coordinates to locate the point on the current coordinate system relative to the origin. So for example, if I were to go to the line command and I wanted to start it, I could use the interactive method, where I just click and it starts it wherever it happens to be. I could do the line command again, and I could use the absolute coordinates, and I could say 2, 3. And there we go. Relative rectangular coordinates, the format is at x, y. You type the x and the y coordinates relative to the last point. There are relative polar coordinates. The format is at distance less than angle. Type a distance and angle relative to the last point. And there's direct distance entry technique. Specify a second point by first moving the cursor to indicate a direction and then entering a distance. The last thing we're going to do before we move on to an example problem is do a little bit of setup on our grid style. In the status bar area, I want you to right mouse click on snap mode and choose snap settings. In the drafting settings dialog box, select the snap and grid tab if it's not already selected. Change the grid style to display dotted grid in 2D model space. Once you've done that, go ahead and select OK, and you'll see that we now have a different grid style.